This is chapter 14. Here is some basic information. The calculations will always be in terms of count. The degrees of freedom is the number of categories minus 1 for goodness of fit, and rows minus 1 multiply columns minus 1 for independence and homogeneity. The distribution graph is always right-skewed, and they are always straight to the right. Chi-square will always be a positive value. If we reject HO, we need to show an example for discrepancy, as we don't need to do anything if we fail to reject. Now we have an example problem for goodness of fit. This example is about number of car accidents per day while talking on cell phone. Step 1. We need to have a test. In this one, the test is chi-square test for GOF at alpha level is 0.05. The new hypo is observed counts of accidents per day are equal to the expected counts of accidents per day. The alternative one is at least one observed counts of accidents per day is not equal to expected counts of accidents per day. Step 2 is the data from SLS. In this one, we don't know. All expected counts greater than or equal to 5. Yes, all expected counts are 99.857. Step 3 is about the calculations, and this is the formula for chi-square and homogeneity, also for the independence. And the chi-square is in this question is about 200, and the degrees of freedom is 6, because we have 7 days a week, and it's always categories minus 1 for goodness of fit test. And the p-value is about 0, and this is the graph, and we can see it's right skewed and it's shaded to the right. Step 4, since the p-value is about 0, which is less than alpha, we reject null hypothesis and conclude that at least one observed count of accidents per day is not equal to the expected count of accidents per day. For example, we expect that there should be about 100 accidents on Saturday, as there were only 12. However, this is only valid if all above conditions are met. So the conditions are those two things. We have a problem for independence. Below is the distribution of grades for two assumption coach professor. This is Professor Colin, and this is for Professor Gold. Step 1. Chi-square test of independence at alpha level is 0.05. The HO is there is no association between professor and grades. HA is there is an association between professor and grades. And there is one thing we need to note. If we are doing a homogeneity test, the HO will be distribution of grades are the same for both professors, and the HA will be distribution of grades are not the same for both professors. And these are the two conditions we need to meet. So we need to find if the data is from SRS, and it is, and all expected counts greater or equal to 5, yes. And we just need to type our data into matrix, and the first one is for the observed, and this one is for the expected. Step 3 is about calculations. Chi-square formula is always the same, and in this one we can just use chi-square test since we have observed and expected values from matrix A and B, so we just plug them in and use chi-square test. It will give us chi-square results and p-value, also the degrees of freedom. Step 4, since p-value is less than alpha level 0.05, we reject HO and conclude that there is an association between professor and grades. Professor Colling appears to be a harder grader. He gave out 3 A's, but we expected there to be 6.67. This test is valid only if all conditions are met, so the conditions will always be the same.
And that's it.